Hello guys, welcome back to Inside Electronics. So in today's episode, let me show you what is the difference between a true RMS multimeter and a non-true RMS multimeter. Basically an averaging multimeter. But for that, you have to keep this waveform in your mind till the entire length of this video. At first glance, this may look like an AC square wave, but when you're zooming it, you can see that it's actually a PWM waveform with modulation happening on both the positive and the negative half cycles. You can clearly see that happening right there. So the main difference between a true RMS multimeter and a non-true RMS or averaging multimeter is that true RMS meters are designed to operate with non-sinusoidal waveforms like these, whereas the averaging multimeter or the non-true RMS multimeters, they are designed and calibrated to measure just AC sinusoidal waveforms. They cannot accurately measure anything else other than just basic pure sinusoidal waveforms. So today we are going to make some measurements using true RMS and non-true RMS, both in the voltage and current range. And for that, here I have some multimeters with me. So let me show you those meters. So these three are our contestants for measuring a non-sinusoidal waveforms. The first one, this is a Wattage. It's a basic multimeter. It costs around 250 rupees. You know, it's the most typical beginner's meter, much like the yellow colored Chinese one. This is the main star of the show. This is the Fluke 324. It's a true RMS clamp meter. So this is going to show the most accurate reading on today's test. This is the Metravi 260TR. It's an analog multimeter. Again, just an averaging multimeter, not a true RMS meter. It's the only analog meter that I got, so I just included that in the test. So first of all, let's measure some voltages and then let's measure some currents with these meters. So let's begin the test with the analog multimeter first, and I have set the knob to 50 volts AC position, and when measuring across the IGBT, you can see that it is reading around 23-24 volts AC, which is not correct. The actual value is much different, but this meter is showing a reading because the movement is actually caused by the magnetic field created by the AC signal that is being measured, and that is the reason why this meter is at least showing some kind of reading even though the signal is not sinusoidal. And these analog multimeters often show readings for square waves also, which of course is going to be a wrong reading. And by the way, let's move on to the next multimeter for the test, which is going to be the Wattage. So this multimeter will be the equivalent of all Chinese cheap multimeters, the yellow colored ones. And here I have set the meter to read 200 volts AC, and it is not reading anything. It is showing something like 4, 5, 10, some kind of random values. But if you're trying to measure a non-sinusoidal waveform with these Chinese meters, this will be the result. You cannot read anything with these kind of cheap Chinese meters. So next, the star of the show, the Fluke multimeter, the true RMS multimeter, and you can see that it is giving around 27.3 volts AC, which is the actual value at that position. So this is why you actually need a true RMS multimeter. If you're trying to measure these kind of non-sinusoidal signals with any kind of other averaging meters, you cannot get a proper reading. You have to have a true RMS meter if you are trying to measure a non-sinusoidal waveform. These two meters are okay if you are measuring just AC signals like normal AC, the 50 Hz AC in your house. Especially this one, this is actually designed to operate much with DC signals and the normal 50 Hz AC signal that is in your home. That's where you can use it. This one also, both can be used for DC and AC applications, AC being the 50 Hz AC, and for general purpose like measuring capacitance, resistors and things like that. But if you're trying to measure a non-sinusoidal waveform, keep in mind that you are going to need a true RMS multimeter. Now the voltage tests are all complete. Let's move on to the current measurement test. So for that, again here I have the Fluke 324, the true RMS multimeter. I'm going to set it to AC amps, and this next multimeter, this is the Fluke 362. This is a non-true RMS meter, or let's say an averaging meter. Again, let's set it to measure AC current, and let's put it across the IGBT to see how much AC current is flowing through the circuit. And here are the results. Here I have kept it across the IGBT, and you can see that both the meters are showing 3.2 amps AC. The only difference being the Fluke 324 has a higher resolution, so it's showing two significant digits after the decimal point, whereas the non-true RMS meter or the ROG meter is showing just one digit. And that's the only difference. At least keep in mind that I'm talking with reference to clamp meters. I'm not talking with the reference to the series connection meters like the normal meters that you put the meter in series to measure the current. So I'm not sure how that is going to reflect the difference in the true RMS and non-true RMS level. Now just to prove that it doesn't make any difference if it's an averaging meter and a true RMS meter within a very well reputed brand like Fluke, right now I'm measuring using an average meter and it is showing 190, 180 volts, which is wrong. And just because it's a Fluke, it doesn't make any difference because it's an average meter. Whereas this meter right now, when I'm connecting it, it is showing 106 volts, which is correct. So it doesn't make any difference that even if you're using a Fluke or Keysight or whatever be the highest reputed brand that you can buy, if it is an average emitter, then it's not going to give you a correct reading if the waveform you are measuring is not sinusoidal. So I hope this video was useful. Thank you for watching. See you with another video.